Okay, so far we've said that there are 5 people out of 1,000 who use cocaine, and when they take a drug test, it is going to work and it will be accurate 97% of the time. So if it's accurate, 97% of those 5 people will get a positive result, 0.97 times 5, which is about 4.85. So 4.85 people will have positive. And it will be wrong 3%. So 0.03 times 5. 3% will get the wrong result, which is 0.15. 0.15 people. Okay, and maybe I'll switch this bit here to be red, like positive versus negative. And then people who don't use, we are going to have a positive result as well as a negative result. Now, the positive result is incorrect, right? They should not be getting a positive result on a drug test if they are not cocaine users. So positive result is going to be that it's going to be the 1%, so 0.01, because it's accurate 99% of the time. So 99% of the time it gives you the correct result, which should be a negative ending. So let's see, 0.99 times the 995. So that means 985.05. 985.05 people will get a correct negative result. But 0.01, which is 1% of 995, will get a positive result when they really don't actually use cocaine. So 9.95 people. Okay, so the key thing here is positive versus negative, right? Result, and the idea that if it's accurate, it is telling, yes, they use cocaine if they use cocaine. If it's accurate and they don't use cocaine, it will say that they got a negative result. Okay, so this is just to kind of work through how many people get a positive result, a negative result, based on which side of the tree they fall on. Now, here's the question, and this is like the actual point of the problem, which is asking us what percent of people who test positive are actually cocaine users. So this is going to really get at the accuracy overall. So let's think about this. We want what percent of people who test positive. So people who test positive, that's like our overall total pool. And we want positive plus cocaine user. Okay, so the total people who test positive, that's our total pool. So here are people who test positive, and here are people who test positive. Now notice they are not all people who actually use cocaine. So our total people who test positive are 4.85 plus 9.95. And then we want people who are positive and cocaine users, right? So this is positive and cocaine users over here following the branch. Okay, so it's going to be 4.85. I'll kind of color code that. Okay, so if I do that division, 4.85 divided by 4.85 plus 9.95 for my total. And I move my decimal point 2 places over. It looks like it's 32.77%. So that means that 32, or maybe round up to 33% of people who get a positive result actually use cocaine. So it's kind of interesting that most people who get the positive result are actually not cocaine users. And that's really coming from, if you look back at the tree, the fact that most people are not users. And even though it's only 1% over here, if we look back at the tree, 1% of 995 is going to be a lot more than 97% of 5. So it's just really coming down to the size of the numbers. Okay, now here's an example that you can work through. This one doesn't give you a total amount of students, but just assume that there are 100 students total to make it easier. Apologies for this being about a flu epidemic. Okay guys, here is the worked out example. So feel free to pause it and compare to yours. and I tried color coding it to see high temperatures versus low. And just remember, in order to get to something like the 31.5, that's just me taking 0.9 or 90% of the 35, right? Just kind of multiplying those out. And then notice I tried to highlight at the bottom for where I got my total people with high temperatures. That's anything at the bottom I highlighted yellow. That's the total number of students that have a high temperature, no matter if they have the flu or don't. And then we specifically put the high temperature and the flu on top because we wanted to know what are the chances that if I have a high temperature, I also have the flu. And it looks like it's a pretty solid bet that if you have a high temperature, 80% chance you have the flu. There's a little reflection question at the bottom just for you to consider. Think through what kind of clues typically are happening to indicate that you use the tree method. Typically, these kind of problems look like this. They have multiple percentages, and they also have kind of yes or no's or two conditions is what you might be noticing. A very common example of this nature is a factory making parts and having parts that work and parts that have a defect or a problem in them. Okay, so thanks for sticking around with me a little longer just to kind of look through and talk through the table and tree problems. That's it for today. I'll see you guys later. Bye.